Hey everyone, and welcome back, Prepa Tec Santa Anita students. I'm super excited to be with you today. What we've got for you is a special explainer designed specifically to review your weeks 1 and 2 materials on matter and the environment. We're going to be taking some pretty massive global concepts and breaking them down so you can see exactly how they fit together. Here's our quick roadmap for today's review. 1. The Earth and us. 2. Understanding climate change. 3. Impacts on our world. 4. Measuring our footprint. And 5. Connecting the big picture. All right, Section 1. The Earth and us, the macro context. Let's kick things off with a big question right off the bat. How can the way we live actually affect something as impossibly large as the Earth's climate? It can kind of feel like a disconnect, right? But I want you to challenge yourselves to think about how your everyday routines, the electricity you use, the food you eat, how you get to school, all of that requires resources and produces real environmental impacts. And look, if you find this hard to wrap your head around, you are absolutely not alone. There's this brilliant point from the Veritasium source material that notes climate change is a bit like the movie Armageddon, but instead of a giant asteroid hurtling toward us, it's an invisible, odorless gas causing a gradual warming over decades. See, our brains are literally hardwired to react to immediate visible threats. An asteroid? We get that. But when the threat is a gradual, invisible change, it can sometimes feel boring or just really hard to grasp. And that is exactly why we need to dig into the underlying mechanics. Which brings us to Section 2. Understanding climate change, the mechanics. So the absolutely crucial thing to remember here is that this isn't just some random list of facts to memorize. It's a very clear causal chain. It starts with Step 1, human activities, things like agriculture, deforestation, and burning fossil fuels. Step 2, those activities release greenhouse gas emissions, like carbon dioxide and methane. Step 3, this leads to an enhanced greenhouse effect. Step 4, that creates an energy imbalance in our atmosphere. And finally, Step 5, that imbalance results directly in global warming. The physical mechanism here is pretty exact. Solar energy reaches the Earth, and normally a lot of that heat would just radiate right back out into space. But those excess greenhouse gases, which are produced primarily by industry and transportation relying on fossil fuels, well, they form a barrier. They act like a giant blanket, preventing the heat from returning to space, trapping it in our atmosphere, and completely disrupting the planet's energy balance. Now, I gotta clarify something really important here. The natural greenhouse effects, that's actually a good thing. It acts as a layer that traps just enough solar energy to keep our planet hospitable and warm enough to sustain life. Without it, Earth would literally be freezing. The real problem is human intensification. By burning fossil fuels and destroying carbon sinks like our forests, we're dramatically increasing the concentration of these gases. We are taking a perfectly balanced natural system and just throwing it completely out of whack. Section 3. Impacts on our world, environmental and social. So what does this actually look like for us? Well, we can see these physical changes manifest as direct, real-world consequences. Rising sea levels directly threaten coastal cities, bringing pretty devastating social consequences with them. Because as oceans warm up from all that trapped heat, the water literally expands. It's a process called thermal expansion. Combine that expanding water with melting glaciers, and you get severe coastal flooding, which forces entire communities to face emergencies and displacement. And honestly, it's a massive domino effect, what we call cascading effects. As temperatures rise, sea ice melts. Now, ice has high albedo, which just means it's super reflective and bounces sunlight away to keep the Earth cool. When that ice melts, that reflective power drops, which causes even more warming. Meanwhile, our oceans are doing heavy lifting, absorbing about 90% of the accumulated excess heat. And as they absorb more carbon dioxide, they undergo ocean acidification, which is devastating to marine life like coral reefs. All of this disrupts our water cycles, causing prolonged droughts in some areas, intense flooding in others, and ultimately leading to really severe social issues, things like food insecurity, climate refugees, and intense conflicts over scarce resources like water. Okay, moving to Section 4, measuring our footprint, quantifying our part. The ecological footprint is formally defined as the biologically productive area required to provide the resources we consume and absorb our waste. I really want you to lock in on that twofold definition. It measures the stuff we take from the Earth, sure, but also the trash and emissions we make that the Earth then has to figure out how to absorb. Your ecological footprint is actually incredibly diverse. It's not just one single thing. We're talking about the built-up land for our cities and homes, the grazing land and cropland for our food, the fishing grounds, the forest land for timber, and, this is a massive component, the carbon footprint, which represents the forest land needed just to absorb our CO2 emissions. Every little bit adds up. When you actually calculate your own footprint, you're going to see a few specific metrics pop up. You'll see global hectares, or GHA, which measures the amount of land and water needed to supply your resources. You'll see your carbon footprint, which tracks the specific greenhouse gas emissions you're responsible for. And hey, that links right back to the global warming mechanics we were just talking about. You'll also see consumption categories that break down exactly how your food, your shelter, and your mobility are contributing to your overall impact. And sometimes, doing this calculation hits you with a pretty shocking number, like 3.1 Earths. This is a classic example of the number of Earths metric. It simply means that if every single person on the planet lived with the exact same resource demand and lifestyle as the person who took the test, humanity would literally need 3.1 Earths just to sustain itself. Finally, Section 5. Connecting the big picture, the microcosm. In your coursework, you guys learned about the fish game. It's this brilliant, beautifully simple simulation of our real-world resource challenges. The core objective is super straightforward. Just have as many fish as possible by the end of 10 rounds. But as you probably noticed when you played, a really direct parallel starts to emerge. In the game, if every player makes selfish short-term choices just to maximize their immediate catch, the shared resource of the fish population gets rapidly depleted. And eventually, everyone loses. This perfectly mirrors the real world. Our collective ecological footprint, which is driven by our short-term individual consumption, depletes the Earth's biocapacity and drives long-term global warming. It shows exactly how individual choices have massive, sweeping consequences for a shared resource. In the real world, we actually track this exact kind of depletion with a metric called Earth Overshoot Day. This is the precise state when humanity's annual demand for natural resources exceeds what the Earth can regenerate in that entire year. When you calculate when Overshoot Day would land based on the lifestyles of specific countries, a pretty scary trend emerges. For a lot of places, it hits incredibly early in the year. We're talking March, April, or May. From that day forward, we are operating on an ecological deficit. Our daily consumption habits dictate exactly when this day lands. So, Prepa Tec Santa Anita students, I want to leave you with this final, vital thought to carry with you as you review this material. Your consumption requires energy, transportation, and resources, all of which generate the very greenhouse gases driving climate change. You understand the mechanics now. The two things are completely connected. So ask yourself, what kind of difference are you going to make in your own ecological footprint to help push Earth Overshoot Day closer to December 31st? Keep that in mind as you prep for your exams. You've got this, and I'll see you next time.